Okay, so you've determined that you want to create an audio plugin. And probably the way you chose to do it is the JUCE C++ framework, which is a great framework with a very friendly API that you can use to create audio applications and audio plugins. So what's the way to go about it? Well, one of the most popular ways is to use the Producers. But the Projucer, so it's an application that allows you to generate a platform-specific project, a C++ project using JUCE. So the Projucer is kind of limited in what it can do. So is there a better way? Or maybe you directly jumped into this video wanting to learn how to use JUCE and CMake together. So in this video, I'll guide you step by step how to create a repository from scratch using JUCE and CMake. Hi everyone, this is Jan Wilczek from WolfSound.com, and if you're new to this channel, here you can learn how to process sound using self-written software. And in order to write some software, we need to create some project structure. We need to decide for some technology that we want to use. So one of my favorite ways to build C++ projects is with CMake, because above all, it's a cross-platform tool that allows you to generate platform-specific projects, C++ projects, and easily build them and test them. What is also great, CMake has a new tool which is called CPM Package Manager, and it's really nicely integrated with CMake. So it makes using third-party libraries really, really easy. So we want to use JUCE, we want to use CMake with CPM, and we'll also look how we can integrate unit tests using GoogleTest, which is another third-party dependency. So as you can see here, I have an empty repository. So what we can do about it? Well, what we can do about it, we can create a CMake project. So once again, what is CMake? If I type here CMake, I should be taken to exactly to the web page of CMake. And from here, you can download and install CMake, and you can put it into your path so that you can use it from the command line. And actually, CMake is the only prerequisite in this tutorial, apart, of course, from your platform-specific C++ tools. Okay, so let's verify that I have CMake installed. So I type CMake -- version, and indeed it is installed. It says CMake version 3.26. Okay, so how CMake works is it's based on these CMake lists.txt files, which determine what our project should be. What's the structure of our C++ project? So let's go create CMake lists.txt. And here we'll define the main structure of our repository. So the first thing that we need to write here is CMake minimum required. And here we specify the version of CMake that we would like to use. So this line is mandatory in each CMake list.txt file. It says which features of CMake we want to use, but I mostly don't pay so much attention to it. As you can see, I'm using version 3.26. Here I wrote 3.22 because it's a version I trust. So I think the newest feature of CMake that we want to use is the C++ 23 standard, which is from like CMake 3.20. So let's stick with this setup for now. Next thing that we write is this project. So I'll call this audio plugin startup, or maybe starter. Okay, so the project itself doesn't do any C++ specific stuff. It just sets up some environment variables that we can use later on. So don't confuse this with creating any application or library. Next, what I like to do typically is I set the CMake CXX standard to 23. So this allows me to use the newest C++ standard, and I believe with the Greenfield project, we should always start with the newest C++ standard. If you disagree with me, then please let me know in the comments why that shouldn't be the case. So The next thing that I would like to set up is I would like to integrate JUCE, right? That's the point of this whole video. So in order to do it, I need to use what's called a CPM package manager. So let me maybe briefly show you. If I now type in CMake CPM, okay, here we go. You have this CMake CPM tool right here. And what's nice about it, I think it's in this folder. No, maybe it's here. Ah, yeah. So exactly, here is the script that we would like to use. So let me just display a raw version of it and let me copy it. So we'll create a folder called CMake where we'll put our CMake includes, and here I'll create a new file called cpm.cmake. So let's paste it here. And basically what it does, it downloads CPM to the location specified by us. So I want to use the newest version of CPM, which at the time of making this video is, I think, 0.38.2. And I typically adjust this folder just by removing all these. Okay, and now we need to specify where do we want our CPM to live. So for this, I go once again to the main CMake script, and here I say that I want to have something like a lib directory, and I want it to be equal to CMake current source directory. So that's the directory in which the particular CMake list.txt file is, and let's call it libs. So it will be the folder where all our third-party libraries live. Okay, so yeah, let's just replace it with the lib directory, and I think we should be able now to use it. So the last thing I need to do here, I need to include this little CMake script. So now I can readily try to run CMake and see what happens. So it should, in theory, it should download CPM because I have not downloaded it yet. So the way to run the CMake scripts, the way I like to do it is I specify CMake-S, and then I give the source folder where the top level CMake lists file lives. So it's the current folder. And then I type -b and I specify here the directory I want to generate our C++ project into. So as you can see, it runs some checks. It creates the build folder, and it should download the CPM package manager. And indeed, you can see it downloaded the CPM package manager. So, and it also created this folder libs. So as you can see, we have our CPM here. And that's a good point already to start creating our git ignore file so that, you know, the build folder and the libs folder are ignored. They are not checked in via the git version control system. So one thing I can do, I can initialize a repository in this folder. And now if I navigate here, you can see that I can add the git ignore, I can add CMake lists, I can add this little CPM script. That's all I would like to do in the git repository, but the libs folder and the build folder are ignored, and that's very good so, because I want to have them separate from my repository, because they are either third-party dependencies or the build folder is automatically generated every time. Okay, so the next thing that we can do, and it's very, very nice, we can use this CPM add package command. And here we can basically download the dependency that we want. So we can specify that we want to download JUCE. And the easiest way to do it is, once again, let me go to the browser, and let me specify JUCE framework, and let's have it on GitHub. Here it is. Okay, and what's nice about it, I can see that the latest release is 7.0.5. But before we do that, let me just copy this. And the great thing is that I can simply write here GitHub repository, and I write JUCE framework / JUCE, and it already knows which repository I'm referring to. So now I'd like to check that I have the right version. So I could specify a version if this git tag had this tiny v before. Unfortunately, it doesn't have it. So what I need to do is I need to go here and type here git tag. So that's the tag that I want to use, and only then I can type version and type this tiny, sorry, I just paste in the version. If the git tag had this tiny v, then I could simply skip this line and it would work right away. But unfortunately, that's because JUCE doesn't follow this convention that CPM package manager uses. We cannot use it like this. And the last parameter that you want to use here is you want to say into which directory this should be downloaded. So normally it would use some default directory, but we don't want to clutter our file system. We want to keep everything local in this repository. That's what I like to do. That's what makes code navigation quite easy. And yeah, now let's simply run again our CMake script. And what I expect will happen, it should download JUCE. As you can see, that's exactly what happens. So everything that was before does not need to be run again because CMake cached some result in the build folder. But now it really downloads JUCE, and it will take a while because, you know, JUCE is quite of a big framework. But ideally, if we don't remove this libs folder, which we basically shouldn't do throughout the work on our project, then we need to run it just once. And then we can reuse the result on and on. All right, as you can see, the JUCE was successfully downloaded, and all that was supposed to be added to our CMake build was successfully added. So the great part is that we can now readily use JUCE. So we could already start working on our plugin. So the last thing maybe that I'd like to do is that I'd like to add a specific check. So let me show you what I mean. So if the compiler is the Microsoft compiler, I want to add compile options, and I want to add all warnings. I want to add treat warnings as errors. And the same I want to do for GCC or Clang. So this is this enforces that all the warnings generated by the compiler are treated as errors, and we set the highest warning level, so all the possible warnings will be generated. So here are the corresponding options of the Clang and GCC, and we're basically done with the main CMake lists file. So now we can really start working on our plugin. So for this, I'll create a folder called plugin. And here I will create another CMake lists.txt. And what I can do here, I will copy over the minimum required version, and I'll say project audio plugin. And what's also important in this particular case, here we need to specify the version because it's something that is required by JUCE, actually. So now we can go here and we can already start working with our plugin project. Maybe the thing to do here is to create the directory structure, so it will be easy to see what I would like to do. So here I'll write, let's say it's your plugin name, so the name of your plugin. That's how I like to structure the include directory, so the directory with the header files, so include and then followed by the name of the library or the application. And now here I want to create a folder with the source files, and these two folders need to be now populated. So what we'll do is we'll use JUCE's template. So it's a template that also the Projucer uses. And I think it's here, examples, plugins. No, it's not here. Is it here? Yes. Okay, great. So here there's an example with CMake. You can see how such a file looks. So we'll simplify this a little bit. So first let me just copy the header files to my your plugin name folder, and let me copy the CPP files to the source folder. Great. So perfect. And now we can already add our plugin. So in JUCE kind of adds its own CMake commands, so that creating JUCE projects with CMake is much, much easier. And in this case, it's rightly so. It says JUCE add plugin. So here I'll just specify the project name as the name of the plugin project. And then there are a bunch of fields that you can fill. So let's maybe specify a few of them. So we have company name. So of course my company is WolfSound. And is it a synth? No, it is not. And then we have a few other options like needs MIDI input, and I'll say that it doesn't need. Then needs MIDI output, and it also doesn't need. And then we have all the additional stuff, so plugin manufacturer code. So I'll say WolfSound and plugin code, maybe audio plugin. And then here's the important bit. So which formats I want to generate, I'll just focus on VST3 because it ships with JUCE, so I don't have to download any external SDKs. And finally, there's the product name. So I will say that it's just your plugin name. All right, and let's see what happens now if I run the top level CMake script. So nothing new happened because I haven't added this directory, right? So I need to call add subdirectory, and I'll say plugin, and only then will, let me maybe minimize this, only then will CMake go into this folder, this plugin folder, and execute this file. So let's see if this will now work. Okay, so we actually generated successfully the project, and I'm on Windows, so I have Visual Studio project, and you can see plugin, and the solution is already here. I'm curious what will happen if I now build this. So the command is CMake --build, and then the name of the folder to which the project was generated. So let's build it. It will take a while because it's the first time I'm compiling this project, and it will also need to compile JUCE. So yeah, as you can see, we got a bunch of warnings here, and because we specified that we want to treat warnings as errors, these warnings are treated as errors, which you can see here. Okay, so what is needed here is a setup that is recommended by JUCE. So they set it up in a way that this build does not produce any warnings. So how to go about it? We need to link some libraries to our project. So, and this is nothing mystical. This is everything that you can find in the official JUCE documentation. So one thing that we are using is that we are using JUCE audio utilities. And this is something that we just use internally, so we don't need to link to it in a public way. But in a public way, we need to link to the recommended configuration flags, to the link time optimization flags. I have missed here this JUCE and JUCE recommended warning flags. Okay, and now we also need to define some compile time definitions. This is also a default way to go about the JUCE project. Okay, and now let's build this project again and see what happens. Okay, and we got a final bunch of warnings. As you can see, they're all related to JUCE using some features that were deprecated in C++23, and we can use exactly what the compiler is proposing us. So we go, if we are on the Microsoft compiler, then we add these to the compile flags. Okay, and now this should work. Okay, great. We compiled the project actually, and the only error we got is the linking error, which is something to be expected. So linking error says that there is a function called create plugin filter, which is not in the compiled source. And that is because this function is defined here in the audio processor, but this file is not compiled at all. So what we need to do is we need to define it here, that we want to compile these two files, and we do it using the target sources command. So we specify here additional sources to be compiled, and these are source plugin editor and source plugin processor, CPP. Great, and I now got an error, compile time error, that these includes are not cannot be found. So these ones, and that is because they are not. I have not specified the include path. So we are here, and the include files are here. So they are in this your plugin name directory, the include directory. So we go your plugin name /, and the same here. But the thing is now that I still need to provide an include directory. So what I need to do is I need to say, okay, target include directories, and this will tell the compiler to look for the headers in the specified directory. So in my case, it's include, and it's just that. So I don't want to include here your plugin name path, because, as I said, it can provide name clashes. It's actually now the project should build just fine. Okay, great. As you can see, everything built. We got no errors. Great, our plugin builds. So you could start developing right away, but there's one additional thing that I highly recommend you do is adding unit tests. And this can be done in the following way. So we create a test folder, and here, of course, we'll need another source folder. And in the source folder, say audio processor test CPP. Okay, and here we will specify our test. But for this, we of course need another CMake lists.txt file. And here we'll define our test project. So for testing, I like to use the GoogleTest library, and it's very easy to do the same thing that we did with JUCE. So let me just Google for GoogleTest GitHub. Okay, here we go. And here we can see that we get nicely tagged release. So we can simply copy this and we'll go cpm add package, name Google Test, and we'll specify version. And for this, we need, again, the name of this repository. Okay. And again, we need to point to the source directory. And finally, there are some options that the GoogleTest demands to be passed in. So we don't want to install it. And we need to force the shared CRT. Okay, so now next thing I need to do is I need to add subdirectory test. And here again, I specify the required version and I go project, audio plugin test, and I go enable testing, which will allow us to run unit tests from CMake. And actually, I need to add it here as well. Okay, so here in the CMake lists file, what we need to do is we need to create an executable that contains our test. So we go add executable, which is specified as a project name. And here we specify the sources. And this will be just audio processor test.cpp. That's the only source. And now what we need to do is we need to go target link directories, target link libraries, of course. And we go project name. And again, we go private. And here it's maybe a little bit tricky. So we need to link first against our audio plugin project, because that's the one that we want to test. That's the one that contains our audio plugin. And we need to link again against Google Test. So that's how the target called, and we're using the main variant because we don't want to write the main function ourselves. We want to simply use the one provided by Google Test. And now we can define a simple test. So I need to include the gtest header. Okay. It's always nice to use a namespace. And here we can define our test. And let's just verify that I can instantiate our audio processor. So how is this audio plugin audio processor? So yeah, I'll do it like this. Processor. And I'll go assert false true, so that I know that my test is failing. I know it compiles just right. So there should be still some problems, right? Because here we're including a header that we have not defined in the include directories. So we go target include directories and project name. And these are again private. And what I need here is GoogleTest source directory. And here I need, okay. So I'm saying this out of my memory. I think it's GoogleTest include something like this. But yeah, that reminds me that we have not yet downloaded the GoogleTest. So now let us run the cpm commands and it will download GoogleTest to our desired folder, as you can see here. So these are checks done by GoogleTest. If they are not found or failed, you don't have to worry about this. So once again, it's GoogleTest, and here is the include directory with the gtest. Perfect. So now let's see which errors we get upon build. So our previous library should compile just fine because it's still the same. So as you can see, GoogleTest built just fine. Okay, and now we get an undeclared identifier error, and that's because I have not include your plugin name, plugin processor. Exactly. And for this, I need to include the relevant directory. So I go, I would go CMake current source directory. We go one level up and we go to plugin and include. Okay. Let's build it again. Okay, and as you can see, it has problems with JUCE headers, so we also need to include the path to the JUCE headers. And this is not a problem because we have JUCE source directory defined thanks to the cpm commands, and here we can just include the modules directory. And now this should be built all right. Okay, and now the final thing that's left to be able to use GoogleTest with CTest. So we need to include GoogleTest here. So this adds a bunch of CMake commands that are specific for GoogleTest, the same way as we added JUCE specific commands to CMake. And now we can just write gtest discover tests, and we give it the project name. Okay, it did build, so now we can verify that the test failed. So we go to the build folder and you just execute ctest. Perfect, we got the test audio plugin, audio processor foo failed. And what it means that the test project compiles, links, and runs just fine. But it also means that our audio plugin project also compiles and runs just fine. What is great about this solution is that here in the build folder, you have the Visual Studio files. I imagine that on XCode it will be similar. Then you can use the Microsoft Visual Studio to develop this project. You can use its CMake integration. You can use Visual Studio Code. I really, really like this. Well, another thing that you can think of is here in the plugin editor and plugin processor. You see they are defined in global namespace. So it would be really nice to wrap it in an additional namespace. What you could also do is define kind of a Git hook that runs on every commit, that it formats your C++ source files according to a predefined formatting. And I use a plugin called pre-commit, and it's really smooth to use, and I really, really like it because then I don't need to think about formatting. It just formats the code on its own. And one more thing that I wanted to mention is also easy to integrate GitHub Actions with CMake. So what you can do, you can actually create a GitHub Actions script or a configuration file. And when you push to the server, for example, on a merge request, a pull request, or on the main branch, it can build the whole, download the dependencies, build the whole project and run the tests. And what is also great, you can also cache the dependencies so that they are not downloaded every time from scratch. And it's really amazing how much flexibility you gain with CMake and CPM. And I hope this template helped you to kind of develop your own gist and understanding also how CMake works. Of course, this repository with the additional tweaks that I mentioned is available on my GitHub. You will find the link in the description below. Feel free to use it as a template for your repository. If you think there's something missing in that template repository, I'd be glad to review a pull request to improve it so that the community can benefit from it. And maybe one more thing to add, there's another template which is very popular. It's called JUCE. It's a very nice template also to use with your JUCE projects. I just found it's quite complicated. It involves a lot of steps, and it may be daunting to someone who comes from the outside and sees all those CMake commands, doesn't know what is which. And it also uses Git submodules to manage third-party dependencies, which I don't like to do. I prefer this CPM approach where I can specify the version, and it's very, very clear to me what happens. So feel free to use that repository. And if you like the video, then please hit the like button and subscribe to the channel. And maybe one more thing that I wanted to mention at the very end is that if you are someone who would like to create audio plugins and you like to learn it, maybe you don't know what it takes to learn it, I have a resource for you, and it's my free audio plugin developer checklist. So it's an actual checklist that lists every bit of knowledge that I believe is necessary to become a full-fledged audio plugin developer. You can get this checklist at wolfsound.com/checklist, and this template should give you a head start on your audio plugin project. So once again, thank you for watching and see you in the next one. Take care.